Hello, my name is Ravan Maziavat Rahman and I will explain about basic of pointer. Okay, before we dive deep into what pointer is, what the actual pointer is, we have to understand what C programming language does in the background. We have a table that contains 3 columns. The first column is address, which is the location of the memory of the block memory address. And the second column is the value of that block memory address. And the third column, or the last column, is how we approach this manipulation in C programming language. Okay, first, we want to set value of 10 in the memory address of 0x1000. One thing to remember that the memory address will be more complicated than this, but we want to make it clear and simple, so we just using a simple number. Back to the topic, how we store this value, which is 10, in the memory address of 0x1000 in this case. We usually do this in C programming language like this. Integer x is set to 10. We know it's basic of C language. It's just declaring a variable and assigning to some value. Now what if the 0x1001 we set the value with the address of 0x1000, and this is just the beginning of pointer. So pointer is a special variable that stores a memory address, not a value directly. In the first row, we directly set the value to the actual value, which is 10. But in the second row, we set the value to the other memory addresses. How we do this approach in C programming language? Now, we do this approach in C programming language using asterisk and ampersand. And this is how we read the syntax. Integer asterisk pointer x is set to ampersand x. What is asterisk and what is ampersand? Asterisk, as I mentioned in this explanation, asterisk is how we declare a variable pointer, and then the ampersand is how we get the memory address of the specific variable. Like in this approach, we are storing a memory address of x in a pointer x variable. Now, the next question is, what if we assign a new value to the pointer x? I give you a second to think what the output will be. Okay, and the actual output will be same as integer x is equal to 20 directly. But we are using this kind of approach. We are using this pointer approach rather than we are using a direct approach like we actually do. And yeah, that's it. That's the basic of using pointer.
In the next topics, we will talk about operator and pointer. There is 2 types of operators that we can use, which is address of operator using and the reference operator using asterisk. I'm going to explain about the address of operator first. The function of this operator is to create a memory address of variable with the address written in hexadecimal, which is 0 to 9 and 8 to 12. The declaration of the variable operator doesn't need to actually pinpoint the real location that is saved within the memory. That is because the location will be determined automatically when the program is running. As you can see here, this is the example of the program. We will declare the variable first and the value, and then we are going to call in the address operator using m_total. The output from this program will not show the value of the variable, instead displaying the memory address of the variable. The example is 459FF82C. Next is the reference operator. Next is the reference operator. The function of this operator is to obtain the value that is saved within a memory address, or to put it simply, it's used to get the content of the pointer value. And here's the example of the program. As you can see, it's similar with the program that I talked about in address operator. But here we are going to declare the variable of this reference operator using asterisk. And then this variable is going to be used to call in the memory address of this variable. And then we are going to display the value using asterisk and variable. The output of this program will display the real value, which is 10. We can also change the value of this variable using the dereference operator. Here we are going to change the display value by using the reference operator. We can change it by changing the value of the variable that is designated to the operator. And we can use the normal function, which is d for a number and then the variable tool. When we run the program, it's going to display 100 instead of 10.
Hello, my name is Muhammad Hafiz and my assistant code is MHZ. So, in this video I'm going to talk about void pointers. Void pointers, or declared as void asterisks, are pointers that don't have a specific data type. Hence, they can store memories of any data type. What I mean is, they can store an integer or a char or any other data type, and they are usually used to typecast data types, like to change between data types, like for example from a float to an integer or integer to a char, and also other more complex scenarios where you need void pointers for more complicated data structures such as linked lists or trees, or even to make generic functions in C, which are functions that has void pointers as parameters, so you can pass any data type into a function. We are not going to explore those examples, and I'm going to show you how explicit typecasting is done, where we do that to access the data that's stored in a void pointer. So here we have an empty program where we'll declare 3 variables. The first one is, for example, grade, where it's 10, and then there's a string where this video's title, or void pointers, and then we have this worker which will store a file. Then we'll declare our void pointer, which is just void, an asterisk, and then the name, for example, pointer. Then we'll assign the pointer into an example grade. But because a pointer is a memory address, we also need to turn this integer into a memory address that points to the integer, which is just the ampersand, the address of sign. Then we will print it. We will print the value of this pointer, and the value is right now is grade, which is an integer type. Then we'll say pointer. Then we'll try to compile it, but it has a warning here, and it says that this format it expects an integer, but it gets a void pointer, and this will get us a rubbish value. But so how can we get the value of this pointer? First, we'll try to dereference it as usual, but there's an error. This is not possible. Then what do we do? Well, we typecast it explicitly. We will tell what type that we want to make it printable, or how to access it. Okay. Then we'll compile it and run it, and it will give us what the value of grade that's also pointed by the pointer here. Then what about the memory address? Will it be the same? For example, this is the void pointer. Then we will just print the address, which is just P, and these two, we will get the address of grade and put an address of operator. We'll compile it, then it will print the same address memory, which means yes, the pointer is pointing. That's correct. It's pointing to the one. Then let's try with the other type, the other values. For example, the pointer will assign it to a string, which is title. We don't need an address of operator because it's already a memory address, a continuous memory address, so their box. Then we'll print what title is. It has what the variable title stores, which is a char pointer into the tr variable. Then also there's also pi, but we need the address of operator because it's only a normal variable. Then we'll print it. Print it, and it's a float. Then we also need this, the reference operator, which will get the value of a pointer. Then the data type, which is a pointer, a float pointer, and then the pointer itself. Okay, so let's compile this. No warnings or errors, and I forgot to put this, the new line. So it matches with all of our variables here, and it's the same pointer assigned to every variable that in here with different data types. And that's it from me, and thanks for watching.
Hello everyone, my name is Daryl with assistant code DAZ, and today we're gonna learn about array and pointer, where this is the sublesson of pointer part 4. Okay, we're gonna next, and let's take a preview of what do we need to learn about this sublesson. So the first thing we need to learn is the relation between array and pointer, why is it important, and then the second is examples of array and pointer application. So we're gonna go to the relation between array and pointer. So what is the relation between pointer and array? Well, in C language, pointers and arrays are closely related and interrelated. Well, an array name is essentially a pointer to the first element of that array, allowing access to array elements using pointer notation, where the pointer of array plus index is equivalent to array of the index itself. So maybe you don't understand what is the purpose to relate between pointer and array, so let's take a concept about it. For the concept, well, you are asked by the lecturer to save a total of 100 calculus grades, and here you get two options where you could create 100 variables to store the percentage grades obtained by 100 different students, which is very annoying and very what do we say about it, very hard. Yes. Or you could just create one variable, well we call it a subscript variable, then that can accommodate all the grades of 100 students, which is much easier, much efficient. And that is why the concept between array and pointer is very important. Okay, we're gonna take a look for the examples of array and pointer application. The first thing we need to see is how to access arrays with pointers. So in here we got nilai praktikan that have value of 70, 80, 90, 90, 100, for English, or in English, 70, 80, 90, 95, and 100. So we're gonna define a pointer. Well, the pointer is gonna point to the nilai praktikan or the array, and we could print the array address by using void ptr on the printf index, and not index, syntax, sorry. So how to access the array value with a pointer? So basically you're just gonna use printf, and then you're gonna wanna use pointer in the summoning value, and when you summon the second value, it's gonna +1. So why is it +1? Because everything in the array is start from 0, and in this value, the 70 value, is starting of the array. It means it located on array 0. Yeah, that's the one. And then you could use loop to access the array value, where do you need to remember that the index is always start from 0. Yes, always. Okay. And then you could print the array value with loop, and this is the syntax, where you could use for, and then you could use this summoning to summon the array value. And then let's move on to the next examples of how to change array values with pointers, where this time we're gonna use 5 different value and a pointer called pointer saya, and then we're gonna point the pointer to the beginning of the array. So the pointer saya is equal to saya punya angka, and this one will point to the first pointer, to the first array, and where the first array is value 10 though. Okay, and then we're gonna print again the value, the all value. So we're gonna access it with printf, and then after we're gonna access it, we're gonna change the array value through the pointer, and this time we're gonna change the third element. The third element is 30, and to change it, we're gonna use a pointer +2 equals to 100. So in this array, the third array will be replaced from 30 to 100, and when you try to print again, the value will be 10, 20, 100, 40, and 50. So that's all for today. Thank you for watching this video, and I'm sorry for, well, my influence, but yeah, that's all for today. Bye bye.
So guys, move on to another topics of pointers, which is arithmetic operation on pointers. So what is it? Arithmetic operation on pointer is. Before we go on to the topics, let me introduce myself. My name is Umar Zaki Gunawan, as within the assistant code with UZY, or you can just pronounce it as UZ. So we go on to the topics. What is it? Arithmetic operation on pointers. Pointers can act as operands in arithmetic operations. This process is often referred to as pointer arithmetic. It is usually used as an alternative notation for arrays but utilize pointers. So you can underline here, which is arrays. The arithmetic operation will only work with pointers with arrays. If you face a problem with arrays, you can utilize the pointers within the arithmetic operation. The condition of arithmetic operation in pointer is only performed with integer operations, and then there are only two operations, addition and subtraction. as an example, you can do +1, +2, +3, or -1, but you cannot do plus 1.1, 3.2, or -1.3. You cannot do that, or you can not times 3 or divided by 2. You cannot do that. So you can only perform integer operations and just subtraction and addition. The syntax is very simple, which is we can declare an array. So that array we store the array on the pointer. Don't forget to add the asterisk on the first before we declare a variable pointer, and then we can do the operation arithmetics on the below. So that you can understand it better, I have an example here. I have an array within which is contain the school, emoticon, the robots, the clown, and the aliens. I want to store the array on a regular variable. So what's the difference between the regular and the pointer variable? The regular variable will know all the content, all the items in the array. So while the pointer variable, I have the pointer variable here, which is I write the asterisk symbol here before the variable, and then we store the array on the pointer variable. The pointer variable will just know the first index on the array. They don't know what's the other items on the array until we do the arithmetic operation on that, so that the pointers will know what's the other items on the array, which is this. On the example here, we add 1 on the pointers, and the pointers will know the index of the pointers is now 2, which is in this array the items, the second items on the array is the robot, and then they know what's the other items. And then another example, if we add 2, and then they know they will move 2 index on the first index, and they know what's the item like that. So for more understanding, I have prepared the code. For more understanding, I have prepared the code here. I have an array in here, integer array of which is contain the 2, 3, 1, 4, and 10. And then we declare a pointers, and then we store the array on that pointers. If we print out the pointer, what will happen? Okay. If we print out the pointer, and the pointer will print out that 2, because if we declare a pointer, they just know the first index of the array. If we do the operation of arithmetics like pointer plus, they will print out 3 on the terminal. If we add, for an example, 3, it will print out the value because the pointer will move 3 index away from the first index, which is 1, 2, 3. So that is of what arithmetics of pointers. Forgive me for the bad English. Continue to the other topics.
Hi everyone, I'm Stephanie Pratama with assistant code SNI, and next we're going to talk about pointer and string. A string in C language is a character array terminated by a no character. Strings also can be represented as a pointer to the first character. A char pointer is used to point to the beginning of a string. The pointer allows access and manipulation of individual characters within the string. When a string is declared as a character array, the array name serves as a constant pointer to the first element. A char pointer provides flexibility in string operations, including iterating through the character of the string, modifying the string, and passing the string to functions. And next we have an example, an array of char str algorithm. Remember, a char pointer is used to point to the beginning of a string. Since we haven't shifted the pointer anywhere, then the string will begin from the first element A. Therefore, when we print it out, the output will be algorithm. And next we are going to shift the pointer 3 to the right, 1, 2, and 3. And now the pointer is in O, which means the string will begin from O. Therefore, when we print it out, the output will be origin. And now let's try another example. Let's say we have array of char string. That's cool. And now let's try to print the original one, which is we haven't shift the pointer yet. And then the output will be descom. This is because we haven't shift the pointer yet, so the string will begin from the first element T. And now let's try to shift the pointer 3 to the right. Okay, from D, the pointer will move to K, 1, 2, and 3, and now the pointer is in K. Therefore, when we print it, it should be start from K. And let's see the difference with print it out. Now, as you can see here, let's as you can see here, now the string it start from K and the output will be called. We're also able to shift the pointer to the left. Let's try it by 1. And from K, the pointer will move to S. And now, let's see the output. After we move the pointer 1 to the left. Yes, and now the output will be SCOM. Thank you.
The next material that will be discussed is pointers as function parameters. Before that, let me introduce myself here. My name is Muhammad Zainal Abidin Abdurrahman, and my assistant's code is Zen. So when we discussing pointers as function parameters, we delve into a crucial concept where we can modify the original data passed to a function rather than just working with a copy of that data. Maybe for some of you guys it sounds complicated, but it is actually quite easy to understand. I will explain this in detail. Before that, I would like to tell you there is 5 agenda here. The first one is the introduction. Second one is the difference from regular function. The third one is function with pointers. The fourth one is the usage examples. So when we will use this material in real life. And the fifth one, the last one, is conclusion. So the first one is, what is pointer function? Pointer function is a function that accepts the memory address of variable as an argument. So when you pass a pointer to a function, you are actually passing the memory address of a specific variable to that function, because the function has direct access to the memory address. It can modify the actual value of that variable. So what is the difference with the normal function? So normally when you call a function and pass a variable like an integer or float and etc., what gets passed is a copy of the variable's value. This is known as pass by value, as we already mentioned in the previous video. So let's look at an example here. In this example, the value of x doesn't change because the change value function, the change value here in this example is ubah nilai. Ubah nilai in English is change value. So the value of x doesn't change because the change value function only modifies a copy of x, not x itself. So it's not direct access to the memory address. So when we want to print out the value of the x, the output will be still the same, which is 10. But if we're using the pointer here, the pointer function here, I will be explaining you one by one what happened in this case. So integer a, integer difference a, this is called, this star symbol is called difference, right? So integer difference a, this means a is a pointer to an integer. It stores the memory address of an integer variable. And then the change value, so the change value in Indonesian is ubah nilai. Ubah nilai in English is change value. Change value operator ampersand x, here we pass the address of x to the function. So a inside the change value, right, will point to x. So a will be save the value of this variable x, which is 10. After that, difference a, operator difference a is set to 20, meaning that we access and modify the value stored at that memory address, which is the value of x. So before we change it, right, the value is 10. After that, the value will be 20. So when we want to printf this one, print off the value of x, the output will be 20. So you can notice some difference here, right? So in this example here, the output will be 20. And after that, this is the usage of the real life case when we want to use pointer as parameter function. So what happened in here? So what happened in here is passing address. Swap, tukar in English means swap. Swap ampersand x, comma ampersand y is pass the address of x and y to the swap function. So in here, the difference A save the value of x, which is 5, and the difference B save the value of y, which is 10. After that, in here, there is modifying values. The swap function here change the values pointed to by the pointers A and B, meaning the actual values of x and y are swapped. So we'll create the variable here named temporary, integer temp, and then the temp value will be the value of difference A, which is save value of x 5. So the temporary is set to 5. After that, the difference A, which is x, which is equal to x, will be set to the different will be set to y, which is 10. After that, the y in here will be set to the variable temporary. The variable temporary is equal to 5, right? So x will be 10 and y will be 5 after the swap process. So what can we conclusion in this video? So using pointers as function parameter in the C programming language is a very useful and efficient technique. So in C, when you pass an argument to a function, it is typically passed by a value, right? Meaning that a copy of the data is made. The function operates on this copy, and any changes made inside the function do not affect the original variable. However, when you pass a pointer to a function parameter, you are passing the memory address of the original data. So why this is important? Why we need to learn this? Because for instead of copying large amount of data, you can pass a pointer to the data, which is more efficient in terms of both memory in your computer and also the processing time it takes. So the efficiency, the flexibility is much better rather than just using the pass by value technique. And if we want to modification of original variable, it will be much easier to use pointer as parameter function. I think that's it. I'm sorry if my explanation is not clear enough. Thank you.
Alright guys, so by far, what do you guys think about this specific module called pointer? So yeah, as you can see guys, now you're on the 7th module, and this specific module is one of the hardest things to learn, specifically because we programmers tend to avoid to talk about it. Maybe you were wondering why I say that, because basically if you already get the idea, then it's fine, but if not, then it's also fine. Well, we only cover the basics of pointers, and for me, myself, Immanuel Ebenheiser Joseph Aletheia, with my assistant code NUE, also being said as Noe for my short name, I'm going to teach you the last matter of this subject, called structs. So structs is also the part of pointer in our module here, but I'm going to teach you for just a basic knowledge about structs in C. Structures is basically the same as structures, but in shorter. Okay, so yeah, we're still gonna learn about pointers, but at the end of this video only. Okay, so don't worry, don't rush it. Okay, it's gonna be quite a toll because yeah, pointers also hard, and you guys really have to be scared about it.
Okay, so without any further ado, let's just jump right into the presentation. Alright guys, so now we're just gonna head into structs. In today's specific topic, especially in this part of the video, we're gonna talking about basics of structs, array of structs, hierarchical structures, pointer to structs. Let's head into the basic of structs first. Structs or structures are a type of data type that can store various other data. A bunch of type of variable into one whole data in the form of a record. Sometimes when you want to group data that has criteria such as full name, age, date of birth, and so on, it can be stored into one category of data in the form of person using the struct data type. How do we create a struct in C? And this is the way we do it. The creation of a struct has the following provisions. There are three, with the most known way to make a struct. The first provision: the structure data type must begin with the keyword struct and is followed by a structure name representative. It's optional, which is then open with the open curly brace sign and closed with close curly brace at the end of the struct creation. Second provision: to shorten the naming of the struct, the keyword typedef can be given before struct, becoming typedef struct, so that the struct name can be called directly without having to use the struct keyword continuously. The third one is the concept of naming its representative in double quotation mark with the name of its struct variable follows the general rules for naming variables. Okay, without any further ado, let's head into the practical session. And now when we run this, we get a regular answer for the output of the program. It's the person name and the person's age. So, how do you use typedef then? Alright. So before, we know that placing the variable name here will be the variable that is being derived from the struct name, but instead now this specific place will be exactly where the representative place of its struct's name should be here. So now the program should work. Yeah, it works. So this person will be its representative struct name of using typedef. And so person is basically the struct that is consisting of name and age. Just that, it's simple. So now, without any further ado, let's head into the next topic. Second one, array of structs. We have created a simple struct that can store personal data, full name and age. What if we want to store various personal data in one struct? After studying arrays from the previous modules, we can apply the same concept to the struct. The concept of an array of structs will greatly help us to store all data in the same category with a large number of capable amount of data, and can apply the concept of sorting and searching data, which will be studied in the following modules. So now we're just going to be focusing on how to deploy array of structs. Let's head back to the coding session. So now if we run this program, we will get Immanuel Hafiz Bustan as what we expected from here. Just that simple, alright? Without any further ado, let's jump on to the next topic. This one will be a hierarchical structures. What is this exactly? So let's read the description first. This structure or record can store various types of data. However, what if we want to store data in a structure that is used in another structure? Of course we can, because this is a hierarchical concept of structure with the purpose of shortening or factorization various data that can be simplified to be more efficient. This method can be achieved by using struct A to be a data variable in struct B with the intention that struct B has data that can be simplified into struct A. How do you do this exactly? Let's go on the coding section again. Don't forget the new line, and let's run the program. Oh, yeah, we got an error here because I forgot to put author at the front. So now it works. But here's the thing, it fails. And because we use release date instead of book rating. And now we got it correctly here. Ta-da! Nice. That's lovely. So, hierarchical structures is basically you store another structure in that specific structure, which is refers to its original structure. So this structure refers to this structure, which is being declared outside of this outer structure. That's basically it. It's just for only just simplification. You can already write the author's name in here, but that's just gonna make things a bit more messed. Factorization, it also works that way. So, okay. Now for the last topic. We're gonna be talking about pointer to structs. Pointer to structs. Creating a pointer to struct can be categorized like creating pointer variables in general. That is, simply add asterisk, it could be more than one, before the name of the struct variable. We use the period sign to access the fields of regular structs, as you guys already see before, just now. But if it is a pointer type, then to access the fields, use the dash right arrow sign. This pointer to struct data can be used to access a struct outside its declaration area in a different function, for example. Because the access process is carried out using the memory address of each field, which is called indirect access, which does not change its original physical value directly. How does this work? Just simply, these things just like how you do with normal pointers, but in this scenario, you work with structs and just it's still in the same concept, so don't worry that much. Okay, so let's get right into it. And now we call it. It works just fine. And now what's gonna happen if I try to modify the first person age. Let's say it's 20. And now we're printing it again. But we're printing it in the second person's age. And it is changed also. So why? Why is that? It's because it's just the way how pointer works. It's just like how you've learned already about bunch of pointers in C. Specifically for arithmetical pointer stuff. Okay? Now, the beautiful thing of a pointer is that you can change the value inside it outside of its declaration place. We declare and initialize this struct specifically in the main function. We can use this thing outside of this main function. So now, let's try to apply that. Change person identity. We're gonna use first person. And the new name will be Hafiz. And the age will be just 20. You see, this function does not accept pointer to struct. It's just a regular pointer with a variable called p. What will happen exactly after this? It is not being changed. And that's why it's because this type of variable is not a pointer to structure. So how do we do that? First, we have to make this into a pointer to struct type of variable. And we have to reference this thing because we use the first person. First person is not being a pointer to structure already, so we must reference it first. And if you do that, we get an error because now p is a pointer type, so we must change this dot period style accessing the field with the dash right arrow. And now it works. So doing this is the same as doing this second person. So if I comment that out, and this works. If I comment this thing out, it will also works. So because second person is already being a pointer to structure, we don't have to reference it back. Reference it to a pointer to struct again. So yeah, that's all for today's video. Thank you very much for watching, and see you on the next module if I will be present. See ya!